Hi there and welcome to Learn Science. And so today we're going to do a past paper review of chemistry, separates, higher, the November 2021 paper, which is when it was released, and it's going to be paper 2. Now, to use this video effectively, please make sure you pause and try the questions before we go through them. So the first part to our question 3 is: diesel oil is a mixture of hydrocarbons that can be obtained from crude oil. State the name of this process used to separate diesel oil from crude oil, and it's worth 1 mark. So let's get into what actually is crude oil. So crude oil is a natural finite resource, which means it will eventually run out. Can't just use it. It's found deep underground, tend to get it in things like oil rigs, places like that. And it's a complex mix of hydrocarbons. It's got loads of different chain length hydrocarbons. And remembering that hydrocarbons, we've actually come across this already in this paper, are made of carbon and hydrogen only. Always write only, it's sometimes worth an extra mark. So here are some examples of some hydrocarbons. Okay, so again, just to show you the displayed formula, we've got alkenes and we've got alkenes. Remember, alkenes are ones with single bonds. Alkenes are ones with double bonds. So you can have lots of different hydrocarbons. And then another example is something like C70H142. So that's just its molecular formula. So you can have any with from 1 carbon all the way up to 70 carbons. So we've already mentioned that crude oil is a mixture of hydrocarbons. So we've got small chain hydrocarbons in there with a few carbons in, and we have long chain hydrocarbons in there with many, many carbons in, and obviously hydrogen as well. So to separate them out, we exploit the boiling point of them. Long chain hydrocarbons have a much higher boiling point than short chain hydrocarbons, and just a reminder that boiling point, we're going from liquid to gas. To do this, we use a process called fractional distillation. So in the fractional distillation column, it starts really hot at the bottom and it gets cooler towards the top. So we heat crude oil in a furnace outside of the fractional distillation column, and then it enters the column as a vapour, as sort of in gas form. Then we have different segments, so every time we reach a certain segment, the vapours condense whenever the temperature of the column is cool enough, and then as remembering that condensing is gas to liquid, then as the vapours condense, we can pull out the liquids at each of these segments. So working our way up, we've got bitumen, fuel oil, diesel oil, kerosene, petrol and gases. It is worth remembering that you need to know all these, and you need to also know the uses of these. This question is specifically asking us, however, about diesel oil, although we don't need the use for this question. It is just worthwhile remembering that diesel oil is used for some cars, not all of them, because the cars use petrol, and also trains. So next we have a multiple choice question that diesel oil contains alkanes. These alkanes are part of a homologous series. Which statement about compounds in this homologous series is true? So we've got the same chemical, same empirical, same general, and same molecular formula. So let's break down what each one of these means. So we've got the chemical formula, which is kind of all the atoms or atom. It can be singular, that one, and the amount of atoms you've got. So for example, H2SO4 or NH3 tells you exactly what you've got and how many of them. Next one is the empirical formula. It is like the chemical formula, however, it's in its simplest ratio. Empirical formula, simplest ratio, should all mash together in your mind. So for example, C4H8 in its empirical formula is CH2. The simplest ratio of carbon to hydrogens. The general formulas, I think of it like a rule. So you've got CnH2n plus 2 or CnH2n, which are rules for alkenes and alkanes. So the other way around should be alkenes and alkenes. And molecular is like the chemical, except you need to have more than one atom to have a molecule. You need to have some sort of bond in there. Putting that together, it's C. So next we have a balancing equation question or an equation question. So whenever we have one of these questions, the answers always tend to be somewhere buried in the sort of words that come just before the question. I'm hoping you'll kind of see what I mean by that in a second, but we just need to really make sure we read that carefully because the answer is in front of us almost here for this one. So when fuels such as diesel oil are burned, the high temperatures produced can cause nitrogen and oxygen in the air to form a pollutant, nitrogen dioxide. And then it wants us to complete the balanced equation for the reaction. And we've got N2 plus 2O2 and then a blank space. So what does the question tell us? So it tells us that when you've got nitrogen plus oxygen in the air, you get nitrogen dioxide. Straight away, there is your product given to us in the question. So now if we break down kind of what nitrogen dioxide actually is as a chemical formula, we need it in that version for this question. Our chemical symbol for nitrogen is N, and our chemical symbol for dioxide is O2. The di means there's two of them. Okay, think carbon dioxide. You've got one carbon, you've got two oxygens. Okay, so nitrogen dioxide there is our product, but our equation isn't balanced. Remember, you can't just make up atoms out of thin air, and you also can't just get rid of them out of thin air. You've always got to have equal number of atoms on both sides of the equation, so on the reactant side and the product side. So looking into this one a little bit more, our reactants, we've got 2 nitrogens and we have 4 oxygens because we've got 2 lots of 2. So we need to make sure that we account for that 2 in front of it. In our products, we've got 1 nitrogen and we've got 2 oxygens. So what we need to do is we need to balance them. So to get from 4 to 2, I should actually say to get from 2 to 4, I've done the arrow the wrong way around there, but we need to times it by 2 on the product side to make sure that we have equal numbers. If we times the products through by 2, we will have 2 nitrogens to match up and we will have 4 oxygens to match up. So just the arrows go the wrong way there. I also want to mention that if in doubt, please just guess 2. If there's a balance and an equation question in there, most commonly it is 2. And that's just a tip I would always tell my exam students. Our next question is explain how the greenhouse effect is caused by gases produced by the complete combustion of diesel oil. It's worth 3 marks, and so we're going to need to be making 3 points. Now, it's an explain question, so remember with explain, we need to kind of state our point and then explain, I guess, what's going on. So we're going to have what gases are produced. We're then going to need to talk about what actually is the greenhouse effect, and then the last thing we need to talk about is how do these gases that are produced in the complete combustion of diesel oil link to the greenhouse effect? How do they cause it? So 2 sort of what's and then a link to provide our how/why for our explanation. So the first bit we're going to talk about is the combustion. There are 2 types of combustion. We have complete combustion and we also have incomplete combustion, and we'll look at the difference now. So complete combustion, the equation is any hydrocarbon plus oxygen gives you carbon dioxide and water. Whereas the incomplete combustion, the equation looks a little bit different. We've got hydrocarbon again plus oxygen gives you carbon monoxide plus carbon plus water. The difference between these is to do with the oxygen, and it's that the complete combustion has plenty of oxygen and the incomplete doesn't actually have enough oxygen. But today we are just concentrating on the complete. And so the gases that are produced by the complete combustion of diesel oil, referring back to the question, are carbon dioxide and water. So it's the carbon dioxide that is what is linking to the greenhouse effect. So if you imagine the Earth, and then the Earth has our atmosphere. And as we get more and more carbon dioxide, this atmosphere becomes thicker. And what that means is when the sun is shining through, the heat is radiating to the Earth, and these gases in the greenhouse absorb the heat that's radiated from the Earth, and heat is re-radiated back down, so it sort of traps in the heat. So hopefully you managed to have a good go at this question, and now we've got the mark scheme that we're just going to go through. So 3A was fractional distillation. C was that they have the same general formula. 3B was C. 3C needed 2 NO2. If you didn't have the 2 in front of it, you would have just got 1 mark because it wasn't quite balanced. And the last question was an explanation linking carbon dioxide and water produced from the combustion. The gases absorb the heat radiate from the earth and re-radiate the heat back down into the atmosphere. You were allowed to write the formula for combustion, and you're also allowed to write traps the heat, which is when I think of greenhouse, that is what I think. I think allows trapping the heat like a greenhouse. Okay, so thank you so much for watching. Please make sure you subscribe so you don't miss any exam questions or any revision tips. And also, if you have any comments or questions, please do let me know in the comments. I'm happy to help you out.